So this is a video tutorial just showing how my Max 3D visualizer controlled by microcorg works. So this is the rendered finished visualizer. But obviously what's more interesting is how it actually works. This is the Max patch. So this is where it essentially starts. This renders the image box, this jit.gl render. This actually creates the this window, and this is constantly re-rendering every 30 times per second. And what this does is it renders it and then erases the last one, and it does this 30 times a second, so it's always this smooth rendered video rather than, you know, jittery slow one, or one that's so smooth it just causes the whole system to crash. The load bang, this just makes it so that when you open the patch it renders the box straight away. The light position message is connected to the render box. This dictates where the light is actually positioned in this box, and this light position, you can change the settings with this, although I had these settings because this is what I considered the best settings for the light position. This goes down to the lighting enable control, so this actually decides whether the light is even going to be on or not. I had a load bang message load this because I found if the light wasn't on, there was no shadows on any of the rendered shapes, so they didn't actually look very 3D, they just looked like coloured boxes essentially. This is the preset. This is also load to a load bang. This is so it loads the presets of all these integers in these boxes and the floating point numbers. It decides the, well, I'll go over all that in a bit, but that's what that does. So next let's go here. This is the first MIDI in. This allows control from the microcorg in the dials. So the MIDI in comes here, and then there's a MIDI pass. And then it unpacks information here. So if I just turn, I don't know, the cutoff dial, cutoff dial, it understands it's dial number 74, and that's the value for what I turn. And then resonance will be 71. The modulation wheel, it's 1, etc., etc. This is then sent to a rotate message. That's what causes the bars to rotate, but I'll go over further how that works later. It also has pitch bend information coming in, so if I move the pitch bend, it understands that I'm doing that. Although I had to have that subtracting by 63.5, because if I didn't, it would, because you notice when I use the pitch bend, it stretches the bars out. If I didn't have this subtracted, it would always sit at 64 and always be stretched. So by subtracting it, it would always stay at 0.5 when the pitch bend is at neutral. Yeah, and the pitch bend information is being sent through this send pitch bend object, which I made, and that's getting sent to each of these green panels, although I'll go over that in a moment. This is the hotkey control. This allows me to control several things using controls on my computer keyboard as opposed to the microcorg. I'll go over these a bit more later, like I said. Although for now all we need to know is that the escape key pushes this message, which you can't really see because of this, but it says full screen, and that gets sent to the window. So if I press escape, it will make the whole screen go full. This is sort of the audio section. So this enables the audio to digital conversion. So the synthesizer audio is actually being fed into here, which is then converted to audio again here, so we can actually hear it through the speakers. There's also an SF play, which is covered up by all these cables. Although you can see if I just, there you go, you can see that now. the SF play, so you can use the open message to open a message box. So here we go, I can load some backing tracks, sorry. So that's essentially what that does, that loads backing tracks, which I can play. You can then loop them with the loop message. Some of the hotkeys control that. So T will, so I'll just show you. So T opens the file, so you can pick the backing track, and L loops the playback, which is good if you've got a repeating drum beat or something. I'll just open that again. So the audio out, the audio in coming from the synthesizer gets sent to this peak amp, and what this essentially does is converts the amplitude of the audio into numbers. So that's taking in the amplitude of the synthesizer now, converting into floating point numbers. But what I found was the amplitude was normally quite low, so it's less than 1. So I had to multiply that to make the numbers a lot more interesting, so they went above 1 there. This is then getting sent through a send object, and that's getting sent to these green panels, which, like I said, I'll go over. I'll go over now, actually. So there are a total of 37 green panels here. Each one is representing one of the 3D bars in the rendered window. So now I'll go over what is going on here. So each of these green panels has a render shape message, which is each of them is a cube, and then and this renders, sorry, which is so this is being sent to this jit.sketch, and that actually draws the image in the render window. These settings dictate that it's a cube. Here, this controls the color. So each of these settings will change the color of each one, and they're different for every panel because I wanted a different color. This here, so this is connected to a position message. So these 3 controls dictate where they are actually in the window. So this is, we can decide that that's there, or there, or there, or there, etc. Yeah, that's and here is where the amplitude information, so from the peak amp it comes to here. There's the pitch bend information comes into there, and I'm going to go away from the green panel for a while just to explain how everything else works, because it all feeds to here eventually. So I'll go straight over here. So this is another MIDI in object, and this is reading more of the keys. So it comes through the MIDI pass, and then the MIDI note information comes in, and they each get sent through a send object. There's 37, one for each key. And then these get sent down to the bottom, and as you can see, these are all the receive objects for every key. The information gets unpacked and then interpreted here. So the left is the note itself, the right is the velocity. So if I press C, it's saying that's note C, and that's how hard I'm pressing it. So if I press it really soft, it'll be A. If I press it really hard, 105. And it's doing that for all of these simultaneously. This is where it gets interesting. This is the if object, and what this basically is saying is, so this is for low C. This one controls the low C. So and what this basically means is if the floating number coming into port 1 is 48, so if I press C, that's 48. So if it's 48, then send out of port 2 the velocity. So whatever the velocity is, it will come out of there. Otherwise, if it's not, so if it's 50, nothing will come through. So as you can see, if I press low C, it will understand that I want it, but if I press D, nothing will come through. And that's the same for every single one. So this one's C, that's C sharp, that's D, etc., etc. And it's for every single key. But what makes this good is that I can press multiple notes, lift off a note, lift off that note, lift off that note, and lift off all the notes. And it'll always understand what is going on in the MIDI keyboard. It's not just dictated by one note. The velocity is then clipped at 1. So it would come through as 44. I've clipped it at 1, but I'll explain why in a second. Then this is getting sent through the send object, and there's one for every single key press, and then each one of these is going to one of the green panels. So if I go back to the first one, this is where that key velocity is coming through. So this is the amplitude, this is where the amplitude of the synthesizer comes in, this is where the velocity of the key press comes in, and then they are getting multiplied together. So if I press C, there we go, it understands the amplitude and it understands that I am pressing the C note. Notice how this one, for example, isn't registering it, and that's because it knows I'm not pressing C. How this works is that because the velocity of this one is going to be 0 because I'm not pressing it, even if the amplitude signal is coming through, because it's being multiplied by 0, nothing's coming through. However, this one, because when I press it, it sends through 1, that times is by that, and then out comes the amplitude. And that works for all of them, depending on whether you're holding multiple notes, or one note, or taking it on and off, etc., etc. And then, what all this controls is being packed here, and sent to a scale message. And the scale message dictates how big the bars go, and that's what makes, if I just load this back up, that's what makes this happen. So if I press C, oh, you can't really see it. If I press D, sorry, I'll just pick a different. So if I press C, the scale is being controlled by the amplitude, so that's what's making it go big. If I do really quiet, if I turn the volume down on the synthesizer, and that's how that works. And as you can see, it's fluctuating with the actual amplitude. And that's essentially how each green panel works. So the amplitude is affecting the scale, which is what makes the objects go big, and it knows which one to make big by what key is being pressed. A few other things to look at. This is the rendering for the spheres. So if I load this back up, as you can see, if I press a key, there's this sphere rendered. If I press the backing track, can't see it because the camera's turned. If I just give it a second, well, I'll explain other things while that's still spinning back. So this is essentially the same as the green panels. So it's rendering an image, although it's now a sphere rather than a cube. And this still controls the color, this still controls the position, but this controls the scale of the object. So the amplitude is controlling the scale of this, so when I press a key, that dictates how big that goes. The other one is controlled by the amplitude of the backing track, so none of the other information affects that except the backing track. So as you can see, this information is causing that to happen. And how that works is that the backing track information is being sent here to a pcamp, so that's being interpreted, converted to data, and then sent to the scale of the object. So that, you can't see it, but that's essentially how the spheres work as well. Couple of other things. This is another control. So if that keeps going away. So this allows me to change the color. So I can make that blue, let's say, and then now the background's blue. Anything else to cover? Oh yeah, so this is what causes the camera to spin. As you can see, the camera is always turning. And how that works is that there's a metro object, so it's always sending a bang out. And then this counter is counting the number of bangs up to 150, and then it counts down to minus 150. And then that's being divided by 100 to convert it to a decimal point, which is then being sent here, which is then affecting the camera message, which is being sent over to the render window. So this is controlling the camera in the render window. And as it's always turning because of the metro, you can see it's always turning, and it goes back and forth as it goes up and down. So that's really good. That is essentially it. That's a very rough basic tutorial on how it works. It would take me hours to explain how every single thing works. The best way to control this is actually in presentation mode. So if I load it into presentation mode, it makes it all go completely minimal. It has instructions on how to use it. And then these are all the dials, and this is what I was talking about earlier about the hotkeys. So escape will make it go full screen, pressing T will open the files, L will loop the track. This stops the spin, this stops the window from spinning if you want. So if I just make that go big, you can see it's spinning. If I press S, it will stop spinning. If I press S again, it will start again. I just wanted to add that extra control for the user. Spacebar will start the backing track, which will stop it, and then by pressing enter that will enable audio in. So now there's no audio in. If I press the synthesizer, nothing's happening. If I press enter again, it's taking in the audio again. So that's a video explaining how my 3D visualizer works.